In this video, we will discuss about Kirchhoff's law. Kirchhoff is a name of scientist given two laws. First one is what? Kirchhoff's current law, KCL, and second one is what? Kirchhoff voltage law, KVL. In this class, we will discuss about Kirchhoff's current law. So, we already studied one law, Ohm's law, but sometimes we cannot solve circuit by using Ohm's law. Once we are having typical circuit, then Ohm's law is not applicable. Then these laws, Kirchhoff's current law and Kirchhoff's voltage law, we will use to solve circuit. Observe what is the Kirchhoff's current law. It is based what? It is based on the principle of conservation of charge. Observe, KCL is based on the principle of law of conservation of charge. Directly we can memorize this one. KCL is based on the principle of law of conservation of charge. But KVL is based what? Another law we are having, KVL. Kirchhoff's voltage law, it is based on the principle of conservation of energy. Principle of law of conservation of energy. Clear? So, we are discussing Kirchhoff's current law. This law is based on the principle of conservation of charge. KCL, current, so charge. Current, Kirchhoff's current law. Current law is based on what? Charge. Clear? Now, when we use this law in a circuit, observe, in a circuit we are having node or junction. If we are having mesh and loops in a circuit, then we are having what? Node and junctions. Once we are having node and junctions, what about the node and junctions? Node or junctions are having what? Three or more intersecting branches. A point, node or junction is what? A point where two or more branches are intersecting. Clear? Observe this one. This is one point. This is the circuit. We are having only node there. What we are showing, only node is this one. It is a closed path circuit, but we are taking only one node point. So it is looking like. So this is the node of a circuit. Clear? And two or more branches. There are the what? 6 branches are there. 6 branches. 1, 2, 3, 4, 5, 6. 6 branches are there. So node or junction is what? In the circuit, KCL apply where? At the node or junction. And what about the node or junction? Node or junctions are having 2 or more branches. What is the node or junction? A point where 2 or more branches are intersecting. That point is called what? That point is called what? Node or junction. Clear? Now this is the node and there 6 branches are intersecting. So what about the branch? Branch having elements. What about the branch? Branch having elements. So this node is what? These 3 is incoming branches and 3 are what? Outgoing branches. Clear? So Kirchhoff's current law is applied at a node or junction of a circuit. Where? At the node or junction of a circuit. Observe, I am taking one example there. I am drawing a small circuit. Observe this circuit. You studied already in the 10th standard. This is what? One circuit, and this is called both resistor R1 and R2. Both are connected in parallel combination. In the parallel combination of this resistor, we are having this circuit. Clear? Now this is the source, plus minus V current I is flowing in this circuit, and this current that time is dividing into the two parts. I1 and I2, and this is called what? Node. This is node A and this is what? Node B. So two nodes we are having, and that node, this branch, one is this branch, other one is this and this. In this node we are having three branches, and this node is also having one branch, two branch and three branches. Clear? So first we should know the node or junction. Two or more branches are intersecting, they are called what? Node or junction. And what about the branch? Branch having elements. This is a branch, this branch is having active elements. This is a branch, it is having passive element, it is having passive element. So I hope you understand the node in a circuit and branch in a circuit. So what we discussed, branch and node. Clear? Now this is a one node. Three branches are coming to this node and remaining three are going from this node. This arrow marks, it means what? Coming towards the node and going from the node. This arrow is what? Going from a node. So what will be the Kirchhoff's current law? Observe. The algebraic sum of current entering a node must be equal to algebraic sum of the current leaving a node. This is the Kirchhoff's current law. Add the node. What is the Kirchhoff's current law? Add the node. This is the node. Add the node, incoming current. This is the incoming current. Incoming current must be equal to outgoing current. I1 and I2 both are going from this node. So sum of outgoing current equal to sum of incoming current. So only I is the incoming current and I1 and I2 both are outgoing current. So incoming current must be equal to outgoing current. This is what? Kirchhoff's current law. This is what? Kirchhoff's current law. Simple. Not hard. We are having two laws, Kirchhoff's given two laws, Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current, so it is based on principle of conservation of current. Means what? Current is what? Flow of the charges. So based on the conservation of charge. Clear? And what will be the law? We are having circuit and in which we are having mesh and loop, and there are some node or junctions. Then at the node or junctions we will apply what? Kirchhoff's current law. What we will apply? Kirchhoff's current law. Clear? Or at the node or junction, incoming current must be equal to outgoing current. That is called what? At the node, incoming current. Summation of I incoming. Sum of all incoming current will be equal to sum of all outgoing current. That is called what? Kirchhoff's current law. This is what? This is Kirchhoff's current law. Now another way we can define. Only 2 to 3 points we should be memorized. These points are sufficient for the Kirchhoff's current law. First, Kirchhoff's current law is apply at the node or junction. Node or junction is what? Two or more branches are intersecting at a point. That point is called node or junction. Branches are having elements. Clear? Without elements, that will be not a branch. Now law is what? Kirchhoff's current law. KCL will be what? At the node, incoming current must be equal to outgoing current. Like I1 plus I2 plus I3 equal to I4 plus I5 plus 5. In these three are what? Incoming current, and these three are what? Outgoing current. So at the node, incoming current must be equal to outgoing current. So first Kirchhoff's law, you should know what? At the node, incoming current must be equal to outgoing current. Then we will solve and we can find required result. So in another way we can say at the node, what? One definition is what? Kirchhoff's law. One point is that at the node, incoming current must be equal to, at the node, incoming current must be equal to outgoing current. But another way we can say at the node, observe, this is important, at the node, sum of currents, observe, at the node, sum of currents will be 0. Observe this one. At the node, this is a node, and sum of all currents will be 0. sum of all the currents will be 0, but incoming currents are taking as negative and outgoing current are taking as positive. We can take incoming current positive and outgoing current negative. It depends person to person. Once we are taking these currents negative, then these currents will be what? Positive. Once we are taking these currents are what? Negative, then these will be positive. Positive, then these will be negative. Clear? Then we can say sum of the current at the node will be what? 0. So I am taking I1, I2, I3. These are what? Incoming current. I am taking negative signs, negative incoming currents, and remaining I4, I5, I6, they are what? Outgoing current. I am taking positive sign. So the negative and positive will be cancelled and finally we are getting 0. So what? Sum of the current at a node. This is the law. Two statements we are having in the Kirchhoff's current law. Best statement is this one. That's okay. At the node, incoming current must be equal to outgoing current. That is the best statement. But another way we can say, at the node, sum of all currents. At the node, sum of all currents will be what? 0. But we should take either incoming or outgoing. Anyone. Once we are taking incoming negative, then outgoing will be positive. We are taking incoming positive, then outgoing will be what? Negative. Then only we are getting sum of current at the node will be 0. So at the node, all the currents will be 0. Incoming current I am taking negative. You can take positive also. Once you take these positive, then these will be what? Negative. So I am taking negative and these are what? Positive, and sum will be what? 0. And after solving, we are getting this one. So I1 plus I2 plus I3 is what? Incoming currents. And I4 plus I5 plus I6 is what? Outgoing current. So what we can say, at the node incoming current, sum of all incoming currents must be equal to sum of outgoing current. So two statements we are having in the Kirchhoff's current law. So simple. Kirchhoff given two laws, Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current law is based on the principle of conservation of charge. Current, so it is based on the principle of charge. Second thing, directly I am taking statement. KCL is applied where? At the node. And node is what? Node is what? Having two or more branch. At the node, a point where two or more branches are intersecting, that is called node or junction. Clear? And branch is having elements. Then first statement is that what? At the node, incoming current must be equal to outgoing current. That is the Kirchhoff's current law. Second statement we can say, at the node, all the currents will be what? 0. But incoming current taking as a negative and outgoing current taking as a positive. Or we can say incoming current taking as a positive and outgoing current taking as a negative. It depends. But incoming and outgoing, one will be positive, one will be negative. Then only at the node sum of current will be 0. So I hope you understand this topic, easy topic. And why we are studying Kirchhoff's law? We are having Ohm's law, but why this law is there? We are having circuit, observe, we are having circuit, but some complicated circuit we are having where Ohm's law is not applicable. Ohm's law is used to find voltage, current and resistance values. But sometimes we are not able to find these values. Then we will use Kirchhoff's laws and solve the circuit, and then we will apply Ohm's law and we can easily to find the required results. So these laws are very important. I hope you understand this thing. That's all about this class. Thank you so much.